One of the reasons why it is called simple harmonic motion is because it is very simple. Welcome back. I remain your favorite tutor, and today we're talking about simple harmonic motion. We are going to explain the concept. We'll give examples related to this. We'll talk about simple harmonic motion from circular motion, period of a pendulum, energy of simple harmonic motion. We'll derive unnecessary equations needed to execute problem, and then we solve SSE and UTME question. Please, if you are a student or you know anyone that is a student preparing for exam, make sure you are a subscriber to my YouTube channel. Make sure you are my YouTube channel. Everything you need to know and more, they are there to prepare you for exam. Okay, simple harmonic motion. Simple harmonic motion is the periodic motion of a particle or a body such that the acceleration of that body is directed towards a fixed point, which is the center of motion. When we say a periodic motion, we are talking about what? A motion that repeats itself. Example of simple harmonic motion, the motion of a what? A pendulum bob. It moves to and fro. That's an example of what? Simple harmonic motion. It repeats itself. Motion of a mass attached to a spring. It oscillates. Motion, vibration of what? A turning fork. That's an example of what? Simple harmonic motion. In fact, when a body repeats itself in motion, that is what? Simple harmonic motion. For a body to execute simple harmonic motion, the acceleration is directly proportional to its displacement. The acceleration is directly proportional to its what? Displacement from the mean position, which is the center of motion. You can see it here, acceleration directly proportional to its displacement. Then this negative sign here indicates that these two quantities are opposite each other. Or rather, we say it is directed towards the center of what? Motion. So for a body to execute simple harmonic motion, the acceleration is directly proportional to the what? Its displacement from the center of motion. So that's simple harmonic motion. All right, we are going to discuss what? Simple harmonic motion from circular motion. Now, when we have a circular motion, a body observing circular motion, okay, there are examples of that. If, for instance, this is a circle, wow, the circle is very fine. Let me draw one that's smaller. So if you say this is what? This is a circle. This my circle is still not straight, but let's say this is a what? A circle. Wow, this one is beautiful. No, that's very difficult to draw. Let's assume that this is a circle, a beautiful circle. Now, this is the body observing circular motion. Observing circular motion. Now, that if this body move round, go back, move again. If this body move round, back to its point, this same point, that's one oscillation, and the body keeps moving again. So we'll say that this is what? Simple harmonic motion. It is what? A periodic motion. It keeps repeating himself. So the body is observing what? Simple harmonic motion. Let's say this is the center of the circle. This is the center of the circle. Okay. Let's call this the radius. Let's say this is point A, point B, point C, point D, then point E. Already the center of the circle. The acceleration of this body is directed towards the center of the circle, and the body is observing what? Circular motion. So there's an angle here, call it, let's say, angle theta. Let's put this displacement. The displacement from the center to the point right here is what? X. Now this body that is moving has what? A speed, linear speed or velocity. Let's say the body move from point A to point, let's call it Q. Q. From point A to point Q, right here, and then we'll say this is what the distance from point A to point Q. And also the body is also observing what? Angular speed or angular velocity. So at this point it has linear speed, at this point it has angular speed because it keeps moving around. It's not a straight line motion, it's curved, so it has what? Angular what? Speed. Okay, we are going to derive the equations, some necessary equations right here. This is Q. So from this place, from this quantity, angular speed. Angular speed is, that is the angle, which is what? Theta over what? Time. Mind you, theta is measured in what? In radians. In this case, theta is measured in radians. So therefore, the unit for this is what? Radians per seconds. So if this is what? The angular speed, we can say this is equation 1. And also, from here, this is the distance from A to what? Q of the body. The distance from A to Q is what? Arc of the what? Circle. From A to Q, it forms arc of the circle. So therefore, S, which is distance, is what? Arc of the circle. Formula for arc of the circle is what? Theta over what? 360 times 2 pi r. This is the formula for arc of a circle. For mathematics students, you know what I'm talking about. And also, make sure you are on my YouTube channel. There you get to find more about this. Everything you need to know in physics, mathematics, they are there. So therefore, normally, we are solving this in what? Radians. So 360 in radians is what? 2 pi. That is what? 2 pi. Convert the 360 to radians, that will give us 2 pi. So therefore 2 pi will take away 2 pi. So therefore the distance is equals to theta times what? Radius. So there we have it here. Theta times what? Radius. So from here I can say that what? Theta is equals to what? Making theta subject formula, that is the displacement over what? Radius. So I can say this is equation 2. All right. Now from here, from this equation, you can see that we have theta here. We can equally put equation 2 into equation 1. So therefore, I can decide to replace theta right here with what? Displacement divided by what? Radius. So therefore, angular speed is equals to, that is theta divided by what? Time. And what is theta? Theta is what? Displacement over radius divided by what? Time. Let's say time over 1. So we change this sign to what? Multiplication. So therefore, the angular speed is what? Displacement over radius times 1 over what? Time. Okay. And that we have it like this. You see this? I'm going to change it to look something very beautiful. I can say that omega is equals to, this is what? Displacement over time times 1 over radius. Now if you look at these two equations, are they the same? Just take a look at them. You can see that I change. Time is here, I brought it here. Radius is here, I brought it here. But do they look the same? Actually, they are the same. Remember that this is multiplication. And multiplication is what? Commutative. Multiplication is commutative. I can easily change t, put t here, put radius here. And it will give me the same thing. I can interchange these two and it will give me the same thing. Because why? This is what? Multiplication. Multiplication is what? Commutative. It's just like saying 2 times 3 is equals to 6. 3 times 2 is equals to 6. If you interchange it, it will still give you the same thing because you are using what? Multiplicative law. It's commutative. Okay. Now from here, this is displacement over time. And what is displacement over time? Displacement over time is velocity. You know that velocity is equals to displacement over time. So therefore, we replace it here. So therefore, angular speed is equals to velocity over what? Radius. Everything here is velocity, then what? Radius. So this is what? The angular speed. So from here, I can say that the speed or the velocity, as the case may be, is equals to angular speed times what? Radius. So here we have it. This, we call this the maximum speed. Why do we call it the maximum speed? Because it has the highest displacement. The highest displacement of a circle is what? The radius. It has the highest displacement. So we call it what? The maximum speed of a body observing what? Circular motion. This is the maximum speed. Now, if this is the maximum speed, now the speed of any point, at any point from the center of the circle, at any point, let's say point X, from the center of the circle, that's not up to the maximum. The speed at any point, that will be, let's say speed at point X, that's equals to what? Omega, then what? Square root, radius squared minus what? X squared. Now this is the what? The linear speed at any point. Let's say point what? X. Such as this case. So this is the what? Linear speed. Why this is what? The maximum speed. Now for what we have here, let's derive the equation for what? Acceleration in this case. Now for acceleration, what is acceleration? Acceleration is what? Velocity over time, or change in velocity over time. So that is v over what? Time. So right here, acceleration becomes, let me put it here. So what is v? V is what? Right here. That is angular speed times radius over what? Time. So I can see that what? Acceleration is equals to, so this is what? Omega times what? Radius over time. And you see this, radius over time. Radius over time is the same thing as what? Displacement over time. You see displacement. Displacement is a straight line distance. Radius is also what? A straight line distance. It's a straight line distance. So therefore, a distance, a straight line distance divided by time is what? Velocity. So therefore, acceleration is equals to what? Omega times what? The velocity. That is angular speed times what? Velocity. Okay, you're almost there. And what is angular speed? What is the angular speed? What is the speed right here? Speed right here is what? Omega times what? Radius. So therefore, acceleration becomes omega times what? Omega radius. That is, acceleration is equals to what? Omega square what? Radius. This is what? Maximum acceleration. Alright, this is the maximum acceleration of a body observing what? Circular motion. If this is maximum acceleration, now the acceleration at any point x will be equals to what? Let's say omega square, then what? X. And mind you, there's a negative sign here, because this negative sign shows that acceleration and displacement or distance is what? They are directly proportional to each other and they are opposite each other. And also, the acceleration of the body is directed towards a fixed point, which is the center of motion. Now that we have it like this, remember also that we can also get centripetal acceleration from here, from this concept. The centripetal acceleration, you know, from this equation, from here. From here, acceleration is therefore equals to, what is omega? Omega right here is what? Speed over radius. That is speed over radius times what? The speed So therefore, acceleration becomes to what? V square over what? Radius. This is centripetal acceleration. That's the acceleration that keeps a body in what? Circular motion. This is centripetal acceleration. All right. That's that for this. And also, we are going to discuss terms we use in simple harmonic motion. The various terms we use as simple harmonic motion that you need to know. We are talking about what? The amplitude, the period, and what? Frequency. Okay. All right, I'm going to clean this board and then we'll discuss it. It's very simple. Amplitude, period, and what? Frequency. Now, when we talk about what? Amplitude. Amplitude is denoted with capital letter A. Amplitude. That is what? The maximum displacement. Amplitude represents what? Maximum displacement of a body. Now, in this case, in circular motion, what is the maximum displacement? Is what? Radius. So, right here, I can say that what? At maximum velocity, V is equals to what? Omega what? A. I can use A to represent what? Radius. Right here. It is also what? Correct. Because amplitude represents what? Maximum displacement. These are terms we use in what? Simple harmonic motion. You have to take note of that. All right. This is what? Maximum displacement. The same thing right here. I can remove radius here and put A here. I can remove radius here and put A here. It's still the same thing. That's the maximum displacement. So right here we are talking about what? Maximum displacement. And also period. Period is denoted with capital letter T. Let me clear this part. Period is denoted with what? Capital letter T. Now, what do we understand by period? Period is the time taken for a body to observe one circle or one complete oscillation. For instance, if this is a circular motion, this is the body. The time taken for this body to move around to observe one complete oscillation, go back to this point, to the starting point, that is what? Period. The time taken for this body to observe one complete circle, the time taken. So this is what? Period. Very easy. For ladies that normally see their period, you understand what I'm talking about. Because when you see your period, you wait again for the circle to complete. And then back to the period again. You keep seeing your period month to month, month to month. That is simple harmonic motion. It's occurring. That is a periodic motion of something. That aside. Okay. Now, so what do we mean by period? Period is what we say time divided by what? Number of oscillation or number of circle. That is number of what? Let's use oscillation. Okay. Or let's use circle. Number of circle. Then frequency. Frequency is denoted with what? F, small letter F. Okay, frequency. Frequency, we are talking about what? The number of circle per unit what? Time. That is number of circle over what? Time. That's how many times it what occurs. Number of circle over what? Time. That's frequency. Now if you look at these two, they look alike. These two, they look alike. You can see that period is what? Time divided by what? Time divided by what? Number of circle. And frequency is what? Number of circle divided by what? Time. Period is measured in what? Seconds. Frequency is measured in what? Per seconds. Frequency is measured in what? Per seconds. Because time is measured in seconds. This thing has no unit. Number of circle has no unit. It's just a number. So it's dimensionless. So time only have a unit. So period is measured in seconds. While frequency is measured, this has no unit. This becomes what? Per seconds. That's 1 over seconds. So period is measured in seconds, frequency is measured in per seconds. Or we use hertz. We use hertz for frequency, as the case may be. But it can also be measured in what? Per seconds, as the case may be. That's the derived word unit. If you look at these two, they look alike. That means frequency is the inverse of period. Period is the inverse of frequency. That's when you turn it upside down. If you take the inverse, if you take, this is what? Period. If you take the inverse of period, you get what? Frequency. If you take the inverse of frequency, you get what? Period. So therefore, I can say that what? Period is equal to the what? The inverse of what? Frequency. So also, I can say that frequency is what? The inverse of what? Period. You can see it right there. And from this concept, we can say that from what we have here, that angular speed is equals to what? 2 pi over what? That the time taking is what? T, that's period. Angular speed is equals to 2 pi over what? Period. From here, we know that angular speed, let me put it right here again. Angular speed is equal to, that is theta over what? Time. For a complete circle, that is 360 over time. The time becomes what? Period. The body observes one complete circle. And you know that we don't measure in degree, we measure in what? We don't measure in degree, we measure in radians. 360 is the same thing as what? 2 pi in radians converted to radians. Because this is measured in what? Radians per seconds. So therefore, period is equals to 2 pi over what? Sorry, angular speed is equals to what? 2 pi over what? Period. No longer small letter t. We are using what? Capital letter T for a complete circle. So this is also what? Angular speed measured in radians per seconds, which is the same thing as, you know that this is 1 over period, the same thing as omega equals to what? 2 pi frequency. That's it. This is 1 over t, and 1 over t is what? Frequency. All right, ladies and gentlemen, please make sure you take note of all this. We are going to stop here for today. I'll be right back. And please don't forget, we have a lecture center in Benin City, Quests tutorial. Right there, we are taking classes for all students. Science, social science, arts. We are preparing students for what? External exam. And it's amazing. It is very amazing. If you are in Benin City, make sure you are there. In Quest tutorial, what do? We make sure we open your head. We put the book inside. The book must enter. And you are well equipped. We have great tutors that are well skilled in this field, in various fields. I remain your favorite tutor. Thank you, and God bless you.